Hey everybody. So today we are going to talk about two very special right triangles in trig. This is page 6, I believe, in your packet. Yep. So there are two special triangles that happen in trig, and in these two triangles, there's some very special relationships that happen, and we can use these relationships to find missing sides without having to actually use trig. So the two triangles have special names. We call them a 30, 60, 90 triangle. That's this one on the right, because it has a 30-degree angle, a 60-degree angle, and a 90-degree angle. And then a 45, 45, 90 triangle, which has a 45-degree angle, a 45-degree angle, and a 90-degree angle. So these two pictures show you the special relationships between the sides. So in a 45, 45, 90, the one on the left, the two legs, that's what make up the right angle, are always equal to each other. They're always the exact same measurement. And then the hypotenuse is always that measurement times the square root of 2. We're going to do some examples and apply these relationships in just a second. In a 30, 60, 90 triangle, so now your two legs, they aren't equal anymore. So what we base everything off of is the leg that's opposite the 30. It's actually the shorter of the two sides that make up that 90-degree angle. So we actually call this the short leg. That's the basis for our other two sides in this triangle. So whatever that length is, the hypotenuse is twice that long. And then the other leg, so the other side that's making up that 90-degree angle, is that length times the square root of 3. And we call that side the long leg. It's the side that's across from the 60-degree angle. So if we let, that should say x. If we let x equal 1, we can draw a very basic version of each of these triangles. So in the 45, 45, 90 triangle, if we say that one of the legs has a length of 1, that means that the other leg also has a length of 1, and it means that the hypotenuse has a length of 1 times root 2, which would just be root 2. And so what that lets us do is actually find the trig ratios for 45 degrees without having to use our calculator. So by using that triangle, we can fill in the sine, cosine, and tangent of 45 degrees. So for 45 degrees, sine is opposite over hypotenuse. I'm going to use this 45-degree angle here. So the opposite is 1, hypotenuse is root 2. So the sine of 45 is 1 over root 2. The cosine of 45, adjacent over hypotenuse, is also 1 over root 2. And the tangent of 45 is 1 over 1, which is just 1. So we didn't have to use a calculator to find those three trig ratios like we did in the last section because these relationships apply. Okay, so doing the same thing for the 30, 60, 90 triangle. So we're going to let x in these relationships be 1. So x is our short leg. So if the short leg is 1, then the hypotenuse is twice that long, 2 times 1. And the long leg is the square root of 3 times 1. And from that triangle, we can figure out the trig ratios for 30 degrees and 60 degrees without a triangle. So for 30 degrees, so if I'm looking at the 30-degree angle, the 1 is my opposite, the 2 is my hypotenuse, and the root 3 is my adjacent. So sine is going to be 1/2, opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse, the square root of 3 over 2, and tangent is going to be opposite over adjacent, 1 over root 3. Okay, now we're going to use the same triangle for 60 degrees, but for 60 degrees, our adjacent and our opposite sides are going to switch, because from the 60 degrees, the opposite side is the root 3 now, and the adjacent side is the 1. So the sine of 60 is root 3 over 2. The cosine of 60 is 1/2, and the tangent of 60 is 1 over root 3. We're not going to do a ton with these ratios right now, but these 9 values are really important when you get further into trig. And so next year, you're going to do a ton of stuff with the sine, cosine, and tangent of these 3 angles. And this is where those values are coming from. So these are unique because you don't need your calculator to figure them out. If we wanted to find the sine of 50 degrees, we'd have to put it in our calculator to figure it out, just like we did in the last section. But for 30, 45, and 60, we can find all 3 of those ratios just by using the relationships in these 2 special triangles. So what we're going to do with these special triangles is use them to find missing sides. So as opposed to having to rely on our calculators in trig, if we know the relationships between the sides of the triangle, then we can just apply the relationships to find missing measurements. Okay, so I'm going to relabel the 2 triangles with our relationships, same relationships that were given to us at the beginning of the notes. So in a 45, 45, 90 triangle, our 2 legs are always going to be the same. And then the hypotenuse is always going to be that measurement times the square root of 2. In the 30, 60, 90 triangle, across from the 30-degree angle, our short leg, that's always going to be our basis for the other 2 sides. So that's our x. The hypotenuse is always twice that number, and the long leg is always that number times the square root of 3. So what this little table does is it just kind of tells you how to go from one measurement to another in each triangle. So let's start in the 45, 45, 90 triangle. So to go from one leg measurement to the other, they're exactly the same. You don't do anything. So to go from a leg measurement to a leg measurement, you just literally copy the number. To go from a leg measurement to the hypotenuse in a 45, 45, 90 triangle, you're going to multiply your leg measurement by the square root of 2. To go in the opposite direction, so if you know the hypotenuse and you're trying to find the leg, then instead of multiplying, you would divide. So you're going to divide by root 2. Okay, so let's apply those 3 rules to this first set of problems here. So 1 through 6, these are all 45, 45, 90 triangles. So even though only one angle is labeled, I know that the other angle has to be 45 degrees. So once I recognize that it's a 45, 45, 90 triangle, I can apply these relationships, and I'm just going to use these rules to find my missing sides. Okay, so in number 1, identify what you're given. So in number 1, we are given one of the legs. That means the other leg has to also be 7. And then the hypotenuse has to be that measurement times the square root of 2. So those are the 2 missing sides of that triangle. In number 2, so this time we're given the hypotenuse. This is across from the 90-degree angle. So in order to find one of the legs are going to be the same. So once we find one, we have the other. In order to find the leg, we need to divide that hypotenuse measurement by the square root of 2. So in this one, our square roots actually cancel out, and so we just get that the leg is 3. That means that the other leg is also 3. All right, and number 3, so this time the triangle is turned, it's oriented a little bit different. Notice that across from our across from our right angle, that would be our hypotenuse. So we're given one of the legs, we're given one of the sides that's created the right angle. So that makes the other leg 4 also. And then that would make the hypotenuse 4 times the square root of 2. If you're thinking this looks really easy, it should look really easy. In number 4, so this time we were given a hypotenuse. 9 is the hypotenuse. So to find the legs, we need to divide that measurement by the square root of 2. So in this one, the square root, there's not a square root for it to cancel with, so we would actually just leave this as our final answer, and that's also going to be our measurement for leg Y. All right, so I want you guys to pause the video and try number 5 and number 6 real quick. All right, so in number 5, we're given the hypotenuse. So to go from hypotenuse to leg, we divide by the square root of 2, nothing cancels, so that would be leg for V and also for U. In number 6, we were given a leg. This is one of the sides that creates the 90-degree angle. V is the other side creating the 90-degree angle, so that's where the other 2 goes. And U is our hypotenuse, so it would be 2 root 2. Okay, so with 45, 45, 90, you really are either multiplying by root 2 or dividing by root 2. Just depends which direction you're going. All right, so let's go back up and look at the 30, 60, 90 now. So in a 30, 60, 90, like I mentioned before, everything is based off of the short leg. So you always want to start your problem by identifying where that short leg is, because that's going to be how you get your hypotenuse and how you get your long leg. So from the short leg, if the short leg is X, the long leg is that measurement times the square root of 3. So to go from short to long, we're going to multiply by root 3. Okay, to go from short to hypotenuse, the hypotenuse is twice the length of the short leg. So to go from short to hypotenuse, we're going to multiply by 2. Okay, now if we started with the long leg or the hypotenuse, we would need to work backwards to the short leg first. So in order to do that, instead of multiplying by those 2 values, we just divide by them. So if we start with the long leg and we need the short leg, instead of multiplying by root 3, we would divide by root 3. And for the hypotenuse, if we start with the hypotenuse to get the short leg, we would divide by 2. Okay, so the short leg is the basis for everything that happens in the 30, 60, 90. So you always want to find that first if it's not given to you, because that's how you're going to find the other sides. All right, so let's come down now to the next page. So I'm going to redraw that triangle here just so that we have it to reference. So here's my 30-degree angle. Here's my 60-degree angle. So everything is based off of the side across from 30. That's my X. The hypotenuse is twice that length. The long side, or the long leg, is that length times the square root of 3. So how do you know that something is a 30, 60, 90 triangle, and how do you know that these relationships are going to apply? So if you look at these problems, you'll notice that in all of them, you don't actually have all 3 angles labeled, but if I have a 60-degree angle labeled, like in number 7, if this is a right triangle, if I have 60 degrees here, 90 degrees here, then that means this angle has to be 30 degrees. So it has to be a 30, 60, 90 triangle. Same thing in number 8. If I have a 90-degree angle and a 30-degree angle, then that leaves a 60-degree angle down here, right? So a lot of times they won't both be labeled, but by default, it has to be a 30, 60, 90 triangle, and that's how we know that these relationships are going to apply. So, like I said a second ago, I would always start by identifying where your short leg is. So in number 7, the short leg is always across from the 30-degree angle. So we were actually given the short leg in number 7. It's 7. So to go from short to hypotenuse, that's U in this one, we just multiply by 2. So our hypotenuse here is 14. And to go from short to long, we just multiply by the square root of 3. So 7 root 3. All right, and number 8. So again, here's our 30-degree angle. Across from that is our short leg, which we were given again. So that makes our lives a little easier, 2 root 3. So the hypotenuse is m in this one. So we multiply 2 times 2 root 3. When you have a number under a radical like that, you only multiply the 2 by the coefficient. So 2 times 2 gives us 4. So the hypotenuse is 4 root 3. And then to find the long leg, you multiply 2 root 3 by the square root of 3. The square root of 3 times the square root of 3 is just 3. And 2 times 3 would be 6. So the long leg in this one is 6. All right, so in number 9, so the 60-degree angle is labeled for us. That makes this angle here the 30-degree angle, which makes V our short leg. So we need to figure that out first before we figure out our hypotenuse. So we have the long leg, 5 root 3. So remember that to go from the long leg to the short leg, we divide by the square root of 3. So the long leg is 5 root 3. I'm going to divide that by the square root of 3, and that just gives me 5. So the short leg is 5. And then I can go from the short leg to the hypotenuse by multiplying by 2. My hypotenuse is 10. Okay? So if you don't have the short leg, you always go backwards to find that first, and then find the other missing piece. So even if this problem hadn't have asked me for V, even if the problem was just to find the hypotenuse, I still would have found the short leg first and then found the hypotenuse after that. All right, number 10. So my 60-degree angle would make this a 30-degree angle. So across from that, N is my short leg here, and I'm given the hypotenuse. So to go from hypotenuse to short leg, again, I'm just following these rules. And because you can use your notes in this unit, you can always reference this chart if you forget how to go back and forth between the sides. So to go from the hypotenuse to the short leg, we just divide by 2. So that's what I'm going to do here. So 14 divided by 2 makes the short leg 7. And then to go from short to long, we just multiply that by root 3. So m would be 7 root 3. All right, so we're going to pause the video again, and you guys try 11 and 12 on your own. All right, so in number 11, across from the 30-degree angle makes y our short leg. We're given the hypotenuse again. So to go from hypotenuse to short in the 30, 60, 90, we divide by 2. 4 divided by 2 is 2. And then to go from short to long, we multiply by root 3. All right, and then the last one, number 12. So across from the 30 degrees, y is our short leg, x is our hypotenuse here, so 5 is the long leg. To go from long to short, we divide by root 3. Again, in this one, the square root doesn't cancel, so there's not anything really that we can do to simplify this. We're just going to leave it as 5 root 3. And then to go from short to hypotenuse, we multiply that by 2, which is like multiplying by 2 over 1. So the hypotenuse would be 10 divided by the square root of 3. So again, this section is really just all about applying the relationships. So all of the relationships are outlined for you in this picture. So if that helps you to use the picture to kind of see how things are related, or to use the table tells you specifically how to go from one piece of information to the next. When you're doing your practice for this section though, the first thing that you have to identify is what type of triangle it is. So in your notes, we did all of the 45, 45, 90 together, and we did all of the 30, 60, 90 together. But in reality, these types of problems are going to be all mixed up. So make sure that you identify which special triangle it is before you move on to applying the properties for it. So now you guys have some practice to do with this, and I will see you in the next video. Have a good one.